Hello everyone, thanks for coming along to this session. My name's Joe, I'm a program manager on the Excel team, and I work on formulas and functions and the calc engine, so all things to do with calculation inside the grid. And just some background, I used to work as a financial analyst. I worked as a financial modeler for probably 10 years building corporate takeover models, all in Excel, so spending a lot of time building very big spreadsheets. And then I had the opportunity to join the team to help improve it and do some interesting things. So for the last 5 years, I've been doing this. And there are a lot of things that I learned over those 5 years that I never knew before joining the team. And I'm going to share some of that with you today. Okay. So this is a 400 level session. We're going to go in pretty deep. We're not going to cover some of the basics because we're going to assume that you're familiar with writing formulas. That you may have seen array formulas. A lot of people aren't comfortable with array formulas, but you have an idea that they exist. You've seen them around, okay? And by the end of the session, I'm confident that you will be the formula expert in your office. Just as long as you didn't bring your colleague along, that would have been a critical mistake. Okay, so, whoops, whoopsie. So this is our agenda. We're going to kick off. We're going to take a look at the evolution of formulas in Excel. Excel's been around for a long time, so there's a bit of a timeline. We're going to talk about dynamic arrays. I'm going to give you a demo. You may have seen that demo a few times. Bear with me. Not everyone in this room has seen it, so we're going to go through that demo. And then we're going to do an evaluation deep dive. We're going to do a quiz just to try and highlight what we know and what we don't know. And then I'm going to jump into describing some of the evaluation modes that we have in Excel, function signatures and how they affect evaluation. We're going to take a look at array evaluation behaviors. And that really is kind of the core. If you understand the array evaluation behaviors, array formulas will be far simpler to work with and understand. And then finally, we'll go back to the array, the dynamic array demo. But this time I'll explain in a bit more detail where those different array behaviors that we've discussed apply. So we'll just revisit that just to explain it a bit better. Okay. So formulas in Excel. Today in Excel, so if you're not running Office 365 and you're not in the Insiders channel, you're dealing with a version of Excel that returns a single value for every formula you write. So you write a formula, you get one value. You want another value, you write a new formula, you copy paste that. And that's just kind of what we've been used to as Excel users. There was always array formulas, but they were kind of this black magic thing that some people did, and there were like significant negatives for that. So not many people resorted to that. Now if we take a look at the history of array formulas, Excel introduced array formulas back at the start. This is the timeline for Excel for Windows. Excel for Windows, version 2 was the first version. Version 1 was actually only on the Mac. And this was way back then. I haven't confirmed if we had Control-Shift-Enter array formulas in version 1. I couldn't find an old enough Mac to go and test it on. I believe it was there, but it was definitely there for Windows. And array formulas have been largely unchanged. Nothing's really changed since then on the calculation front until now. In Excel 365, we are introducing dynamic arrays, which is a fundamental change to the way formulas evaluate and calculate. Okay? It's a big change. And if you're on any version in between version 2 of Excel and Excel 2019, you're going to be using old formulas. And we'll talk about what that means. But this will not be coming to Excel 2019. It's only going to be in Office 365. Okay? So legacy array formulas, Excel 2 through Excel 2019. They were created by this keyboard shortcut, Control-Shift-Enter. So you write your formula and you press Control-Shift-Enter. And you get these curly braces around your formula. You see these curly braces like that. Okay? And what that really tells you is that Excel is going to use a different evaluation mode to evaluate that formula. Those Control-Shift-Entered formulas could span multiple cells. So you could say, select a block, hit Enter, Control-Shift-Enter, and give it a big range, and it would end up committing that to that range. I might even just scoot across here to give you Let's see here. So I'm gonna enter an array formula here. The munit function's been around for a long time. Not many people use it because it's kind of a mathematical thing. This is going to give me the unit array, and I'm going to Control-Shift-Enter that. And you'll see I get these curly braces around it. I get my array formula, and I get this output from a single formula. Now, the negatives, I can't delete that individually. I have to delete it as a group. So that's kind of a pain. If I want to modify that, I have to select everything and modify it as a whole. And there aren't really indications that they belong to a set. So there are significant negatives to Control-Shift-Enter array formulas. They weren't widely used, and people weren't great fans of them. So let me go back. Okay, but they did all the key array logic things. So we introduced that back in the 80s, the array logic in our formulas. They do things like broadcasting, lifting, and pairwise arithmetic. And those things are probably terms you're not familiar with, but by the end of the session, you will understand what each one of those are. Those are the three things that you need to understand if you want to understand array formulas. Okay? And this is just a list of those significant negatives. They can't redimension. You've got to figure out how big they are ahead of time. They're hard to work with. You can't just delete them. You've got to do wacky things, select them as a set. And they're not discoverable. No one's ever going to hit Control-Shift-Enter by accident. It's not going to happen. Someone has to tell you. You have to bump into the spreadsheet. So they're really kind of weird. Now, to fix all of that, we're introducing dynamic arrays. So enter dynamic arrays. With dynamic arrays, Excel's grid natively understands array formulas. And what that means is if a formula evaluates to an array, Excel will just spill it to the grid. So it'll spill to the neighboring cells if there's enough space. And this is really array formulas v2, okay? And here's the key thing. This is the default formula type for Excel going forward, okay? So these are Excel formulas. In the future, that'll just be it. You won't even think about what they used to be. It'll just be dynamic array formulas everywhere. So I'll just go back to this animation. So if you had a formula that was returning a set of names, in the past, we could only give you one name. We would do something called Implicit Intersection. You'll be familiar with that later on. But what we'd do is we'd pull one value from that array, and we'd just pop it into the cell and say, there's your one value. And that's not useful if you're trying to do something like a sort or a unique. And what we do now is we'll spill that to the grid. Okay. Now, with dynamic arrays, we're introducing 6 new functions. Because we've got this new power, we want to give you some fun things to do with that. And we've got filter, we've got unique, we've got sort by, sequence, and rand array. The first 3 are really the hero ones, filter, unique, and sort. And the rest are kind of building block functions. People were doing wacky things in array formulas in the past. They were doing these weird row minus row things to generate sequences that was just inefficient and very difficult to read. So we introduced sequence. Rand array really helps in things like Monte Carlo analysis, where you need to generate large amounts of random numbers and you want to consume them. Now, just talking about some availability, this feature, dynamic arrays, was announced at Ignite, September 2018. It's a core change to Excel, so we've been stabilizing that. We've been working with our partners. They've been working with their add-ins, making sure everything works with this. So it's still coming soon. Currently, we've rolled out throughout Microsoft, so all of Microsoft's using it, our corporate, everywhere we're testing it internally. And we're at a position that we're hoping to progress further through the public rings. So can't give you a final release date, but it's progressing very well. So coming soon. But it's something that's worth understanding now because it's a big change. Okay, with that, I'm going to jump into a demo. If you've been to any of the other sessions, you've probably seen this demo. So just bear with me. It's going to be short, and it's for people that haven't seen it. And then we will revisit this later with our newfound knowledge. Okay, so here I have a set of sales. I've got some products sold. I've got the region they were sold in. I've got units, the price, and the revenue. So actually, I was mucking with this earlier. Let me clean up my spreadsheet. Okay. So the first thing I want to do is do some analysis. I want to calculate the number of units sold for each of the products. Now, you could do a pivot table. Pivot tables have some disadvantages, but you could also use the new unique function. So I go equals unique, and I go and say, give me the unique of this. Okay. The unique function is going to return an array. When it returns that array is going to spill to the grid. So I just hit enter, and it spills. One formula, many values, right? We have a blue border around that to show that that is an array and they're all related. So if I go outside, you'll see we indicate that that is a grouping. On the formula bar, the formula only lives in the top left cell. If you look at the formula on the top left cell, you can see the formula. If you go to the other ones, there's a ghosted formula to indicate it's calculated by a formula, but the formula is not really there. So if you hit F2, you'll see it just evaporates. There's no formula there. Okay. If I type over the top of this, right, hit enter, the formula which is in the top, still there. It just can't spill anymore. There's something in the way. So it rolls up. It gives me a pound spill error, which is a new error type. And when you interact with that error, it shows you where it would like to go. So now that I've got that border, I can go down here and I can just delete the obstruction, and the second I do, it spills. So these things are lightweight. They're not going to damage your spreadsheet. They're not going to overwrite your data. They're just going to roll up if there's not enough space, and they'll let you go and correct the issue, make sufficient space in your spreadsheet. Okay. So now I've got my list. Well, that's nice. It'd be really great if that was sorted. So I'm just going to go and sort that straight away. So I'm going to give that a sort function, sort. The sort function takes 4 arguments. We'll just use the simple version for now, and we'll talk about the more complex variations in a second. So I'm just going to sort that, and now I've got my sorted list. And then I'm going to do a SUMIF. Now, the reason I'm demonstrating SUMIF now is a SUMIF is a function that's been around forever. It's not a new function, and you'll see that we're going to be able to get this thing to spill too, automatically. Before I do that, I just want to show how deeply ingrained dynamic arrays is in our calc engine. So I'm just going to go equals, and I'm not even going to use a formula, a function. I'm just going to say equals A9 through A12. Like, just equals that range. No function anywhere. If I hit enter, it spills. And it took the values from those cells. Oops, I don't need help. So it just took those values and it echoed them because I just said equals the values in those cells, and they just spilled down. Okay. So now I'm going to use it with the SUMIF function. So SUMIF, give it the products over here. Criteria, I'm just going to give it a single one for now. And then I'm going to say all these units over here. And I hit enter, and that'll give me the number of charging stations sold. Okay. Now what you'd do in the past is you'd copy that down, and you'd be done. Okay. But then the next day, they'd come along and update your spreadsheet, or there'd be some new sales. And all of a sudden, oh, VR meeting. VR headset, and the unique list is expanded, but the number of units sold has not expanded because it's being driven. Each formula is just returning one value. So what you need to do is copy that value down. But that's inefficient. You don't want to have to always interact with your spreadsheet, remember to redimension things. You don't want to over-provision because it's ugly. So what we did was we added a new way of referencing arrays or spilled arrays. And you'll see that now. So I'm just going to start off. I'm going to select 3. And if I've selected 3 elements, you see H9 through H12, H11. Well, and I hit enter there, that'll spill. Okay. You'll know why that spills later on. We're going to talk about our array formulas and why this is behaving the way it does. But when I expand to the entire array, we get a new notation, H9 pound. And that says, that's what we're referring to as a spill ref. And it says, get me the entire spill range for the thing that's spilling in H9. Okay? So I hit enter there, and I've got my spill. And when I go along here, and I'm just going to get rid of this VR headset, it's the only one in the list, which will mean that the unique list will shrink, And because my SUMIF is depending on that, the SUMIF is going to shrink too. So now this spreadsheet is dimensioning itself efficiently. It's just growing as to the data that's coming into it. So you don't have to go and make changes to it just because your data's changed. And then the final formula I want to demonstrate is the filter function. Now, this is going to show a couple of things. One of the major things here is that arrays in Excel are just 2D. Excel is the only programming language in the world that only has 2D arrays. We don't have a concept of 1D arrays. We just do 2D arrays. And that's because it maps really neatly to the grid, right? So I'm going to go and filter, and I'm just selecting this entire table. Now, I had some questions at the last session saying, oh, do we need to always use this with named range or named things? No, you don't. The only reason I'm just using this for simplicity of the formulas, otherwise I'd have to go and select the ranges. But you don't have to use a table. You could be referencing the grid, just ranges. So I'm just going to take the sales table over there, and I'm going to include anything where the region equals the value in the cell. Okay. Now, the way the filter function works, first argument is your data. Okay, so you just want an array. And the second argument is an array of Booleans, trues and falses. If it's true, we keep it. If it's false, we throw that row away. So it has to be the same dimensions as your data. And that's what we're going to generate here. And you'll understand why this generates an array later on. But that essentially generates an array. Okay. And I'm going to hit enter. And we end up getting a spilled array, 2D spilled array of all the sales in Kentucky. And I can go and switch that. This has some data validation on just to make it easy to select the different states. But you can see how this is redimensioning. Okay. Now, the magic thing here is the spreadsheet you're looking at is just 3 formulas. That's it. Okay. And it's doing something that would probably have taken a full day to build if you could get there, and it would have had serious negatives in the past because you would have had to have over-entered ranges to deal with resizing. So 3 formulas, only 3 places you can make an error. Okay? It's doing stuff you could never do in the past. And it was way faster, saved a ton of time. So a lot of fun. One of my favorite comments on the forums, I think it was on a Reddit post, someone said it made them feel like an evil wizard. And that's kind of, I think that pretty much sums it up. So I'm going to sort this one. We've got this array spilling on the right. And I want to sort that in descending order. I want the highest sales at the top. So we're going to go back to that sort function we used earlier, but we're going to use a more advanced variation. So if you take a look at the signature, sort, an array, so the thing we want to sort, the sort index. So here we're going to give it the index of the thing we want to sort. We're going to sort on revenue, which happens to be the 6th column. So I'm going to say on the 6th column, and I'm going to say descending. Okay, and that is it. And if I hit enter there, we now have this sorted in descending order. Okay, and it will stay in descending order. So really simple to roll your own analysis, get things sorted, make it look good. So that's kind of an intro to dynamic arrays. We'll come back and I'll explain some of the nuances in here once we've gone through some of the calc topics. So I'm going to switch back. Okay. Let's see. So we're probably going to be looking at slides for the next half hour-ish. So let's dive in. Okay, so these are the key advantages of dynamic arrays: more capable, faster to build, less chance of error. And it's difficult to understate the importance of that last one. Fewer formulas means less stuff to review, means less chance of error, means more reliable spreadsheets. So it's a great advantage to use these wherever possible. Okay, so let's dive in to evaluation. Here's a quick quiz. You're going to score yourself. You're not going to get in trouble if you fail. If you get 100%, don't tell me. You're expected not to get them all right. So you've got 5 scenarios here. The data's all the same. They all have just 1, 2, 3, 4 in the grid. And then we've got 2 formulas. If the formula was entered in old Excel, and if the formula was entered as an array formula or in new Excel. So we're just going to take a look at what that formula would return. Okay. And it's just to highlight where there might be some deficiencies. And they're simple formulas, so you might expect that you know the answer, but you'll see there's some curiosities in there. Okay, so first up, at the top, I've got the old Excel formula, and then I've got an array formula. The old Excel formula is what would happen if you entered in Excel 2019 and before, and the array formula is what would happen if you entered it in dynamic array Excel, or you Control-Shift-Entered it in older versions of Excel. Okay, so you can just think of this as a Control-Shift-Entered formula, and this one is what you have in production Excel today. Okay. So first question, what would happen if you enter that in old Excel? Okay. Well, the answer would be 2. Okay. Maybe not what you expected. We'll dig into that in a bit. I'm not going to tell you why these things do these things just yet. We'll talk about it at the end. If you array formula enter that into C2, you just get 1. Okay, because we're just calculating the value of C2. So what would happen in C2? Okay, so that's the one scenario. Here's the next scenario. In old Excel, if I entered B1 through B2, so equals this range, as a regular formula, what would I get? You get a pound value. Okay. If you array formula enter that same thing, so CSE enter that thing, you end up getting 1. Okay. And I think by the end of this, you will probably be questioning why old Excel is returning what it's returning, and that's the version of Excel you have right now. You'll understand in the end. You'll probably end up spotting that array formula is actually a little simpler to understand. Array formulas currently kind of have a bad rap because people do crazy things with them. They only ever resort to it when they're going nuclear. But honestly, array formulas there's less complexity there. Okay. So if we entered equals A1 through A2 plus 1 into the cell, so equals this range plus 1 in Excel today. Correct. And then if you array enter that, correct. Now we wrap that in a sum. Okay? So this thing, which we had in the previous one, and we wrap it in a sum. The answer is 3, still 3. And if you array formula enter that, A1 through A2 plus 1, and you CSE it or you enter that in dynamic array Excel, you end up getting 5. Okay? And then let me back up 1 second. So keep these in mind. The next slide is really the same thing, except the A1 through A2 plus 1 gets put into a named formula. So you create a name, and you say the name is A1 through A2 plus 1, okay? And I now call that exact same thing, the A1, you've got A1 through A2, which is the name, and I'm just putting it in here now, okay? And I enter that as a regular formula, and now it gives me 5, and behaves the same as an array formula. So what's going on there? Okay. Anyone get 100%? Good. Otherwise you could have taken the rest of the session. So what's going on here? Let's understand what's going on. Why are formulas behaving this way? So Excel currently has 2 grid evaluation modes. Yeah? And they differ on how they treat their arguments. So the default you have today in Excel 2019 and before, and non-dynamic array 365, is the default is what's known as range implicitly intersecting evaluation. Okay? We'll explain what this implicitly intersecting is in a second. And then we have array evaluation. And this is used by legacy CSE arrays, and it's also used by dynamic arrays, okay? And this will be the only evaluation mode in future Excel, okay? If you want to do something similar to what this one's doing, there's an operator for you, and it's the @ operator, which will trigger this thing called implicit intersection, okay? We'll talk about implicit intersection in a second. But implicit intersection is the true difference between these two modes. This one does it, this one doesn't do it. If you want to do it in this one, you've got to ask it to do it. It's not going to do it for you, okay? Okay, implicit intersection. What is it? Okay. Now this is old Excel. This is Excel 2019, 2016. Okay. So here I have the length formula. Okay. Len. All it does is it returns the length of the string that you're providing it. Typically you provide it with one string, and if you provide it with multiple, this is how it behaves in old Excel. So if I enter it over here, it returns 5. Okay. If I enter that exact same formula, exactly the same formula, character for character the same, and I hit enter down here, it gives me 8. Okay. Why the difference? Well, the difference is implicit intersection. The length formula, or the length function, expects one thing. Okay. It's defined as accepting one thing, but we've gone and provided it with multiple. We provide it with a range. So what it does in implicitly intersecting calc is it says, ooh, you've given me a range. I expected one thing. I'm going to pick one from that range. And what it does is it picks the one on the same row or column. Okay. So that's what's happening here. The reason this function is returning 8 is because, and I'll back up one. The reason it's returning 8 is because it's picking cell A4. Okay. It says, I only expect one, so I'm just going to pick one that I feel like it. I'll use as a rule. And that rule is to pick the one on the same row. So it's going to say, I'm just going to consider backbone, and it gives you the result for backbone. Okay? So you get your 8. Exact same formula down here. Error, because there is nothing on the same row. So it says, well, I can't figure it out, so you get an error. And if you do it down here, now there's multiple things in the same column. It goes and errors too because it can't figure out which one are from that column. So that's implicit intersection. And that is the default behavior in Excel today. And that's going away. That is the key thing that changes with the introduction of dynamic arrays. Okay. So actually, so if you wanted to actually do this in new Excel, when you enter, if you wanted this behavior, and very few people want this behavior, financial modelers do want this behavior because they name ranges like foreign FX. And then what they do is they just go, they'll just call it, all their spreadsheets line up. So then if they call it in a particular column, it'll refer to the foreign FX rate on another sheet for the same column. But most people don't want this. But if you did, you can put an @ in front of that. So you'd go len at A2 colon A7, and you'd replicate the same behavior. There's some people still want that behavior. Very few people, but some people. And there's a way for them to do that. Okay. So judging by the puzzled faces in the audience as to why this behaves this way, I'm assuming not a lot of people would be unhappy if this went away, which is a good thing. Okay. So let's talk about function arguments. And when you looked at that length function, you saw the behavior changing based on what the arguments are. So one of the key things under the hood is Excel's function arguments have expectations. And if you give them something they don't expect, they do something that they have a defined behavior for that thing. Okay. So if we take a look, I've just got some examples here. I've got the sum function, and the sum function takes some numbers. I've got square root, it takes a number. I've got the VLOOKUP function, which a lot of people love. It's not my favorite, but there it is. Then there's index and match. These two are way better in my opinion, but there you go. And they take some arguments. And then you have your operators, which you can think of as functions as well, just like two argument functions, right? They take a value, take two values, and they do something on it. They just happen to be written a different way. You could have called the plus function a plus, and then you give it two arguments. But all these arguments have expectations. You can't really see it when you look at them, but you can infer it. So if you take a look here, I'm just going to color code them. So the sum function expects a multi. So multi is a multiple value thing. The sum function is expecting a multi for each of its arguments. The square root function just expects a single value, right? So it's expecting something we call a scalar, which is just a value, right? And then if you look at the VLOOKUP one, this is kind of curious. So it's expecting a value. So this is the thing it's looking up. It's expecting a multi for the table. So it's saying, oh, because when you specify a VLOOKUP, you give it the table. You say, look in this table over here, or this range. So it's a multi. And then you're giving it the column index number, which is generally a number. You can say, give me column 3 or column 4. Curiously, this is actually a multi. So you can provide columns 1, 3, 5, and we'll return columns 1, 3, and 5 with that, and skipping out 2 and 4, right? But you'd have to array into that to have seen it. Not many people have used this. I haven't really seen it used in the wild, but you could, in theory, do it. And then there is the final argument, which is the range lookup argument, which is a true-false. So you say, do an approximate match or not kind of thing. And that's expected to be a scalar. So these are the sort of expectations under the hood. You can see the index function expects a multi, so that's the block it's looking up, and then it takes two scalars. So I want this row, I want this column, okay? And then I'm just gonna skip to the operator over here. Operators typically expect scalars. So there's a single thing on the left plus a single thing on the right, or a single thing on the left divided by a single thing on the right. So they're dealing with scalars. So this is something to keep in mind. Okay, so what is an array? An array is a collection of values. Okay. Unique to Excel, arrays always have two dimensions. Okay, makes it really easy to map arrays to the grid and the grid to arrays. But the important thing is, I'll get to that in a second. I've got some more demos, but we've got here's a 1 by 5 array. So this is not just a 5-element array. We always have 2 dimensions on an array in Excel, right? And this is a 5 by 1 array. And those two things are different, okay? Because they're always 2-dimensional. You can't have just a simple array. You can't say just 5 elements. There's always a direction to it. It's either row-wise or column-wise. And this is a 3 by 3 array, right? So 3 rows by 3 columns. And the key thing here is a range is not an array, okay? Ranges are not arrays. Ranges are ranges. Ranges can be coerced to arrays sometimes, but sometimes not, right? So if you have a function like the row function, you can say what row is A3, and it'll say it's row 3, but you can't say what row is an array. It'll fail because an array doesn't exist in the grid. There's no row it's associated in the grid. So they're actually two different things. You can, if you use the offset function, you can use an offset on a range. You can't use an offset on an array, okay? They're different. Okay. And that difference really comes through in old Excel when you try and do implicit intersection, because we implicitly intersect ranges. We don't implicitly intersect arrays. Okay. So it's another curiosity in existing Excel. Okay. Now, let's talk about creating an array. There are 2 ways you can create an array. Actually, there's a third. You statically create the array, so you just give it a use curly braces and you specify the numbers. So commas denote new columns and semicolons are new rows. I think of the semicolon as just a carriage return. So if you want a new row, carriage return. Okay? So here are some examples. If I go curly braces 1, 2, 3, 4, 5, and I have commas in between, it's going to be a row array. If I use semicolons, it's a column array. And if I use a mixture of commas and semicolons, I can create a 2D array. There have to be as many rows you have to be the same number of elements on each row. You can't have a jagged array. We don't support jagged arrays. The other way of creating an array is by using a formula that returns an array. So in the past, in old Excel, you could use munit. It's kind of a weird one. Your frequency function would return an array, but there were a very limited number of functions that returned arrays in old Excel. The reason being because they were difficult to work with. UDFs could also return arrays. Now, in new Excel, we have the sequence function, which returns an array. We have the unique function, we have the sort function. All those functions you saw before will return arrays. So it's a lot easier to create arrays formulaically these days. And there's this third way of creating it, which is through lifting. Okay? Now, lifting causes a function that doesn't return arrays to return arrays. Okay? And we'll talk about that behavior. Those are in the array behavior section. Okay. So let's talk about array eval. So in Excel today, Excel 2019 and before, the grid is basically the only place that you don't encounter array eval. Everything else is array eval. The grid is an anomaly. Okay? If you use named formulas, those are array evaluated, even in old Excel. Conditional formatting, if you specified using a formula, that's array evaluated. Okay? In the formula bar, if you press F9, that's array evaluated. The formula bar itself array evaluates. I don't know if you've used the F9. We'll see some examples in a bit using that to explain some of the behaviors in the spreadsheet I had earlier. But basically, everything in Excel is array evaluated with the exception of the grid in old Excel, and we're going to make it consistent. So everything's just going to be an array. So it simplifies your life. Now, here's an interesting thing. Are implicitly intersecting formulas the ones that you have right now in Excel non-array? Okay, so we're going to look at a quick example here. So if I have this formula in old Excel, right, equals the sum of that plus that in the sum, right? Okay, and I enter that, I get 2, okay, right? And that's what you'd expect based on that implicit intersection thing I said before. So we've got this plus, a plus is expecting a scalar on the left and right, but you're giving it a range. So it's going to pick one, and it's going to pick the one in the same column. So it's going to pick this one and this one. It's going to add them together and give you 2, okay? So you get the 2. If you Control-Shift-Enter that, you get 18, okay? I'll explain why you get 18 through broadcasting. You'll see that in a second. But if in old Excel, I instead enter 1, 2, 1, 1, 1, plus 1, semicolon, 1, semicolon, 1, semicolon, which is the representation of these things as arrays, and I just enter that. No Control-Shift-Enter, just enter. Just enter. What do I get? I get 18. Exactly the same as Control-Shift-Enter, okay? And that's because regular formulas in Excel today exhibit all the array behaviors except for one exception, and that is implicit intersection of ranges only. They implicitly intersect ranges. They don't implicitly intersect arrays. So formulas today in Excel are kind of array formulas with one exception. So it's kind of a curiosity. And that's why I'm a big fan of us simplifying this all and just moving to array formulas throughout. Okay, so, and I'm told that these lines are perfectly parallel. They don't look it to me, but when I use a ruler, they are. So the world is not as it seemed in the past. Old Excel exhibited all array behaviors except for one, implicitly intersecting formulas. And we'll come back and I'll show you just exactly what it did in a sec. But now we're going to talk about the core of this presentation, which is the array behaviors. What are they? Why? How do array formulas work? How do you leverage them? So the first thing is lifting. When a scalar is expected, when one thing is expected by a formula, but you give it an array, Excel internally says, well, that thing only expects one thing. So what I'm going to do is I'm going to give it each value. I'm going to give it one value from that array. I'm going to get the answer, and I'm going to stitch together a return array. So I end up generating an array as the return array. We refer to that as lifting. Okay. So the square root function, for instance, if I give the square root function an array, so you can see I'm giving it an array 1, 2, 3, 4, right? And if I hit enter there in new Excel, or I CSE enter that, actually, if you regularly enter that too, you'll get the same, because regular old Excel does array calc when given an array. It only implicitly intersects when given a range. So that will end up giving you an array back, and the reason it gives you that array back is because of lifting. So we apply the array to the function, we call the function multiple times, we just construct our own return result. That is lifting. That's the one array behavior. Okay. The next one is pairwise operation. So what we do is when we have multiple scalars, right, and you provided multiple arrays, what we do is we do a pairwise operation. So if I have 1 semicolon 2 semicolon 3 4, so I got this array and I add this array, what we do is we add these elements pairwise, okay, and then we get the return array. Okay, so that's pairwise operation. So we've got lifting and we have pairwise operation. That's 2 of the 3. And then the last array behavior is broadcasting. Okay? Now, how broadcasting works is, you saw we wanted to do pairwise operation. Well, you can only do pairwise operation if you have pairs. So we try and create pairs. Okay? So if I have the array 1, 2, 3, 1, 2, 3, and I multiply it by 3, or I have 1, 2, 3, and I multiply it by a single element array of 3, we want to do these pairwise. So we need to expand this out so that we can then do it element by element. So what we do is we copy that down in the case of a 1 by or a scalar, and then we multiply it across. Okay, so pairwise. If we have an array that is not 1 by, we don't know which element to copy down. So what we do is we just put pound in A there, and then we multiply it across in a pairwise fashion. So we get 3, 6, pound in A. And that's called broadcasting. It's the way we expand arrays to be the same dimension as other arrays in that formula. Okay? And we'll do that for arguments that are scalars. So if you provide multiple arrays as scalar arguments, we will size them all to be the same, and we will expand them using broadcasting. Okay? So those are the 3 behaviors we have in array calc. Okay? That's really it. There's one more called truncate, but that's just to truncate it down to a single value if you CSE enter it. That's really not a behavior dynamic arrays has. So here's a broadcasting example. This is kind of an advanced example. So I've got a scalar, and I'm adding some arrays. The first one's a scalar, then it's a 3 by 1, 1 by 4, etc., etc. To fit them all, we need a 3 by 4 array at the end, because we want to do this in pairwise fashion. So we know our final result size, and we've got all our arrays in between, and then we seek to add them. So we need to expand them all to the same size. So the 1 is easy, we just grow that down, we grow it across. The 3 by 1 is easy, we just grow it across. The 1 by 4 is easy, we expand it down. The 1 by 2 is a little more complex, so we expand that down, that's fine. But when we copy across, we don't know, they could have been different values. We don't know which one we should be copying, so we just fill it with pound in A's. And over here, I've got a 2 by 2. Well, I don't know what to copy down, and I don't know what to copy across, so you get pound in A's, and then we just add them all in a pairwise fashion, and you get the end result. Okay? So that's broadcasting. Okay. And then we have truncating arrays, which exists for CSE arrays, because if you enter it in a single cell, we're just going to pick, you've only given us enough space for 1 cell, so we're just going to give you 1 value back. Okay, or if you give us 2 cells, we're going to give you 2 values back. So we truncate it. So here I've got this, and we end up truncating it. So it's a relatively simple one. Now if we flash back to that sum function, which was returning 18, why was it returning 18? Well, that's because in old Excel, we do broadcast, we add the elements, we sum the elements, got 18. Okay, that's how that worked. Okay. So this is kind of the summary slide. In old Excel, we had implicitly intersecting evaluation, which implicitly intersected ranges only, not arrays, only ranges. It broadcast arrays and it lifted arrays, and they were not self-dimensioning. With array eval, which is coming, and which is the behavior for CSE, no implicit intersection. Implicit intersection doesn't exist. Everything is broadcast, ranges or arrays, and we lift everything, ranges or arrays. And then the self-dimensioning for dynamic arrays, yes, and for CSE, no. They just stay the size. Okay? And if we compare that to other formulas in Excel, so named ranges, or named formulas, conditional formatting, all the rest, you'll see they line up. They line up with the array eval. Okay? So this is really consistent. Implicitly intersecting eval was an anomaly. Okay. So here's a comprehensive example. Old Excel, I take an array, a range, and I add the array 1, 2, 3, and this 1, 2, and 1, 2, 3. So first up, we implicitly intersect. We pull off a single range from that. We end up getting the value from it. We broadcast out, so we resize those things, and then we add them pairwise. And then because this is an old Excel formula and it's a single cell, it's going to pull out one value and you get the value 4. That's what would have happened internally. Okay? If we take a look at new Excel, so this is CSE or dynamic array Excel, you have your array. We end up pulling out the values. We use them all. We don't throw anything away. We broadcast out to go and create the similarly sized arrays so that we can do pairwise operation. We then do the pairwise operation of adding them all. And if it's a CSE, we truncate it. If it's a dynamic array, we just spill. We say, there's your array. That's what you calculated. We don't throw anything away. Okay. So let's revisit that demo I had earlier. And we'll talk about why things behaved the way they did. I think it's okay, you can see that, cool. Okay, so the first one was the SUMIF. So if we take a look at the SUMIF function here, and I'm going to try and make it bigger so people can see. So we look at our SUMIF, right? Now the reason the SUMIF spilled is the SUMIF function signature expects a multi, a scalar, and a multi. Okay, so kind of makes sense. The area we're checking, what we want to sum, the range you want to sum, but the criteria is like a single thing. What do you want? You want to sum, digital projectors, and it'll go sum them all. But when I provided multiple values to that, and it was expecting a scalar, we lift. So we call that multiple times, and we return an array. So that's the behavior you're seeing here. You're seeing lifting. And lifting, the beautiful thing about lifting is it means that every function in Excel can deal with an array. You can provide an array to any argument. Either that argument expects arrays, in which case it'll do what it does with arrays, or if it expects a scalar and you've given an array, it's going to lift. So there is no scenario you cannot provide an array to a function in Excel. You can provide arrays everywhere. So you can do some interesting things. So in this case, we're using lifting. We're providing an array to something you didn't expect it, and we're getting an array returned through lifting. Okay. Now, if we skip across here and we take a look at the filter function we had, okay, and I'm just going to simplify it out. I'm going to get the sort out the way, just so we've got less to look at. Okay, so we've got this filter function. Now, the filter function is interesting. It's expecting, I'm going to do it in a cell because it'll be bigger for you. It's expecting an array for the first argument, and the include is an array of things to include. Okay, so it wants an array there, and we're giving it an array. But if we take a look at how we're calculating the array we're giving it, I'm saying the sales region, which is an array, it's a range, but if I hit F9, you can see that there are multiple values and it's a multi-value range. So if I hit F9, you can see these are all the values coming through from that sale area. It's a great trick, by the way, if you're using Excel and you want to figure out what something's returning. just remember to hit escape, because if you hit enter, that's going to commit that formula. So I'm going to hit escape. So I've got this range, okay, multi-cell range, and I'm saying equals a scalar, M6, single cell thing. So the equals here is expecting a scalar on the left and a scalar on the right. I've given it an array, okay? So what it's going to do is it's going to try and broadcast out that scalar, which is the M6 on the right, to be equal sized to the array on the left, okay? So it broadcasts that out. So I end up with two arrays in memory. I have the one, which is the sales region, and I have this New Jersey, which is now just a whole bunch of copies of New Jersey in an array the same size, and it does a pairwise comparison of each of those, okay? So now it compares them all. Once it's done comparing them all, it returns an array of all the results. So if I select this and hit F9, you'll see it's going to give me a bunch of trues and falses, okay? Whole bunch of them. And just to make this a little simpler to understand, I'm going to really reduce the size of my data. So I've just reduced it to like 7 columns, 7 rows. And you should now be able to see the results. So there'll be 7 trues and falses, okay? You can see it here. Oh, if I zoom out a little, it'll be a bit more readable. Widen it. Bear with me. So I get my 7 trues and falses, okay? The way the filter function works is if it's false, it throws it away. If it's a true, it keeps it. So in this case, it's thrown everything away, which is why I get the error in the cell. For the filter function, you can provide a third argument to say what it should do if there's nothing. So I'm going to say nothing, okay? Now it's returning nothing. Okay. So that's what's happening there. And you can use this in interesting ways. So for instance, let me take a look at my data. Actually, I'm going to undo and get all my data back. If I go and if I want to do, let's say I want to do an OR. So I've got my New Jersey over there, and I want to filter this list to 2 states. Okay. So let me select another state here quickly. So I want to do an OR. So I've got this, which is returning, as we saw, an array. Well, if we generate another array and we add them together, it'll do it in a pairwise fashion, and then that resulting array will be fed into my filters. So what I'm going to do is I'm just going to wrap this condition in a set of brackets, right? I'm going to say plus, and I'm going to go and say, use the same format, so region equals the value in this cell, okay? So I'm expecting to get North Carolina and New Jersey sales come through, and I do, okay? And that is because of the pairwise operation. So this one here is going to generate an array. It expands the scalar, and then it does pairwise operation to generate an array. So I get an array. I get another array from this one. I then add the 2 arrays together. So it's going to add them pairwise. The plus function doesn't know what to do with arrays. It just knows scalar. So it says, well, you give me an array, you give me another array. Oh, they happen to be the same size as they will be in this scenario because I'm using the same sales region, and it just adds them together. If you add 2 trues together, you get, in Excel, a true is something that is, false is 0, and a true is anything that's greater than 1. So we end up adding them together. So if you have 2 trues, you add them together and you get 2, but Excel will treat that as being a true. So true plus true equals true, false plus true equals true as well. So that's how you can end up generating this, essentially an OR function. You can use multiply to do an AND if you're seeking to do an AND. So I'll show you a quick AND here. So I'm going to switch this out, and I'm going to use multiply to do an AND. So what I'm going to do is this state, the first state down here, where the revenue is greater than 70, okay, the value in the cell, okay? So right now I have only my sales greater than 70 from New Jersey, and I can go and change this, and those will be just greater than 100. And that's doing an AND statement by using pairwise operation. So it's broadcasting and then pairwise operation that has caused that. So that's kind of an intro to array calc. So with that, I'm going to switch back to the rest of my slides. And I'll be here at the end if you have any questions or you want to dive in. But this is our Excel community. If you have any questions or you're playing with dynamic arrays or anything in Excel, this is the place to go, provide some feedback, participate in the community. This is where Excel PMs hang out. We also have a number of our MVPs that contribute and just very active community members. Evaluate the session. If you found it useful, I understand it's a 400 level session, so we got down in the weeds a little, but I wanted to explain the way it all calculates and how it all behaves under the hood. And thank you. So I'll be here if you have any questions. Thanks.